Hello, this is a video about discrete probability distributions. First of all, we need to know what this is all about. You can consider the literal meaning of this. This is like distribution of discrete probability. How we are going to find the probabilities and how those probabilities are going to be distributed over certain area. Okay. So let's consider an example of rolling a die once. So you know that the possible outcomes in this case are 1, 2, 3, 4, 5 or 6, right? And if I want to make a table of the outcomes, say I'm going to write the outcomes, which could be 1 or 2 or 3 or 4 or 5 or 6, and I'm going to write the probability of each outcome. Okay, and I can make a table of this. The probability of getting a 1 is 1 over 6, probability of getting a 2 is again 1 over 6, and a 3 is 1 over 6, getting a 4 1 over 6, and 1 over 6 everywhere. So this is a table which has the probability of each outcome. Okay, this is basically how the probability is being distributed, but we will be changing this English part of the table soon. We'll understand what it is all about quite soon. Okay, so in order to understand, let's go into one more example. A bag contains 2 red and 3 blue marbles. 2 marbles are selected at random without replacement. As you could see, this has been highlighted here. Now let's consider those outcomes which has a blue in it. Okay, so we are only going to consider the outcomes which have blue or no blue in it. So we are going to consider the blue, picking up blue marbles. Okay, now how can it be done? In how many ways you have the combinations there? So you can have the first case to be there are no blue marbles. The second case could be there is one blue marble out of the 2 marbles that you are selecting, and both the marbles could be blue. Right? These are the 3 cases that you could have as an outcome when you are considering only the blue marbles as your outcomes. So there are 3 cases. This case would be no blue would be a 0, and 1 blue would be a 1, and 2 blues would be a 2. So we are considering 0 blues, 1 blue, and 2 blues marbles. Okay, so in fact we are only considering these things, therefore we would make a table of values only for 0, 1 and 2. Okay, now if I call this as x, so when the probability, what is the probability of getting a 0 blue, what is the probability of getting a 1 blue, and what is the probability of getting 2 blues, right? For this you need to go into the tree diagram. You know how to make a tree diagram. This is a without replacement question. So you can make it's a red and a blue, and then the red would be 2 reds, so it is 2 over 5, and the blue is 3 over 5. And since it's without replacement, you need to think about how to make the probabilities in the next 2 branches. In this case it would be 1 over 4 because the red is already taken here, and this would be 3 over 4. And in this case it would be 2 over 4, and here it would be 2 over 4. Okay, so this is how the tree diagram would look like. So in the cases where we are looking for 0 blue would be this branch, right? Therefore probability of 0 blue would be 2 over 5 times 1 over 4. Okay, probability of 1 blue would be the branches of this or this, right? So which would be equal to 2 over 5 times 3 over 4 plus 3 over 5 times 2 over 4. And you can simplify this and bring it to any answer you want. What is probability of both of them being blue? And it's obvious, so this is the track that you should be going, would be 3 over 5 times 2 over 4. Okay, now instead of writing them as 0 blue, 1 blue and 2 blue, we call it as probability of x is equal to 0, and here we write it as probability of x is equal to 1. Mind that I'm using the capital X here. Okay, so this x is number of blue marbles in the outcome, right? This is what this x means here. Okay, and this we call here as random variable, because this is going to be the variable in this case, and we are going to call this as random variable. So this random variable in this question can take three values: 0, 1 and 2. Okay, so going back, you can write the probability distribution table like this. For each probability of x equal to x, where x can take 0, 1 and 2, would be, for 0 it is 2 over 5 times 1 over 4, which is equal to 1 over 10. So this could be 1 over 10. And then if you go for probability of x is equal to 1, the probability of this is 3 over 10. Okay, so this will be filled as 3 over 10, and then this would be 6 over, sorry, this is 4, 6 over 20, which is 3 over 10 again. Okay, so this is 3 over 10. Okay, okay, sorry, this should be 3 over 10 plus 3 over 10 should be 6 over 10. Therefore this is 6 over 10, which could be taken as 3 over 5, but still 6 over 10 would be better. So this table is called the probability distribution, discrete probability distribution. It's discrete because the value of x 0, 1, 2 is discrete. Okay, therefore this is called discrete probability distribution. Let's do some example of this. Try these out. There is problem number 1, 2, 3 and 4. Okay, switch off the video for some time, pause the video and try these questions now. Hope you were able to do all the 4 questions. Let's try to solve them and check your answers now. A bag contains 5 blue and 3 green tickets. 2 tickets are randomly selected without replacement. Again, without replacement is a very important thing to note. X denotes the number of blue tickets selected, which means X is the random variable, and this random variable is defined in this question as number of blue tickets. Okay, find the probability distribution of X. So how many values can X take? X can take 3 values, sorry, 5 values, because you have 5 blue tickets there and 2 tickets are selected, right? There are only 2 tickets selected, and you are looking for blue tickets in 2 of them. So again, as in the previous case, there could be no blue tickets. There could be 1 blue ticket, or there could be 2 blue tickets. Both of them could be blue. So X takes the value 0, 1 and 2. So you start writing them, and you take this as small x, 0, 1 and 2, and then the probability of the random variable taking each of the values would be written like this. Okay, and 0, probability of having 1 blue and 2 blue. This should be again done using your tree diagram, which is blue and green, and blue would be 5 over 8 and green would be 3 over 8. And then you'll have another branch, blue and green, and you'll have here blue and green, and you need to fill in the branches here. It's without replacement, so you will reduce the number of blues and number of greens here in the first place. So this would be 4, blue would be 4 over 7, and there would be green would be the same, 3 over 7. And in this case the blue doesn't change, therefore 5 over 7. The green changes to 2 over 7. Okay, so for the probability of getting a 0 would be green, which is 3 over 8 times 2 over 7. Okay, so whatever the answer is, you can simplify and write it there. Getting 1 blue would be 5 over 8 times 3 over 7 plus, this is this way, plus this way, green and blue, 3 over 8 times 5 over 7. And getting two blues is just straight 5 over 8 times 4 over 7. Okay, so these are the values for which with the probabilities of which for each values of x. Okay, this is called the probability distribution of x. We have done this. If instead of 2 tickets 3 tickets are randomly selected, find the probability distribution of x where x is equal to 0, 1, 2 and 3. Yeah, you will have an extra value for x, which is 3, because all 3 tickets could be blue. So you'll have another you can't just add one more column here. This is wrong, because you'll have the tree, one more branch in the tree, and it will be completely different. Okay, so it would be actually a bigger one where x can take 0, 1, 2, 3, and the probability of x is equal to x with the tree diagram should be done here. Okay, let's move on to the second question. Consider the experiment of tossing a coin 3 times in succession. Okay, list all possible outcomes. So a coin has two faces. It is either H, H, H. It could be all three heads, or it could be H, H, T, or it could be H, T, H, or it could be H, T, and T. Right? And then with T, you can have T, 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 H, T, TTH and THH. I think these are the maximum number of outcomes that you can have: 1, 2, 3, 4, 5, 6, 7 and 8. So the total number of outcomes is 8. Okay, if the random variable, now we are coming to probability distribution here, we are considering a random variable x, which is actually number of heads observed. So you can immediately you can check that x could be 0 no head condition, 1 head condition, 2 heads or 3 heads. Okay, now we are supposed to find the probability distribution table. So how do we do that? So you take x values and make the table of values here, and you need to find the probability in each case. What is the probability that there is no head? So you have t for that, which is 1 over 8. Okay, what's the probability that you have just one head? So you have options here. Let me change the color. No, you have one option here and one here and one here. There are 3 places where you have exactly one head. So this is 3 over 8. Okay, how many cases you have 2 heads? So you have 2 heads here, 2 heads, and THH 2 heads here, right? So there are again 3 over 8. And in which cases do you have 3 heads? There is only one case, which is 1 over 8. Okay, if you have observed in these cases, you could see that this plus this plus this plus this is always equal to 1. Okay, you would have noticed it in the previous case as well. If you had noticed here, I think I didn't simplify this. Let me go back. If you simplify this and if you add all these things, you will get it equal to 1. Okay, we can even consider this example, the example that we did. If you add 1 over 10 plus 6 over 10 plus 3 over 10, this gives you 10 over 10, which is equal to 1. So all of them, the probabilities always add up to 1. So we can even check that with the next few examples. So this is another example that we were supposed to be doing. So you are given the probability distribution as a function k times 1 over 3 to the power of x, 2 over 3 to the power of 4 minus x, right? So for finding the values of p of 0, p of 1, p of 2, p of 3 and p of 4, we need to just substitute the values of x as 1, 0, 1, 2, 3 and 4. Okay, so if I am going to write p of 0, then it would be k times 1 over 3 power 0, which is 1, times 2 over 3 to the power of 4. Okay, and p of 1 would be k times 1 over 3 times 2 over 3 the whole cube, and p of 2 would be equal to k 1 over 3 to the power of 2 and 2 over 3 to the power of 2, and p of 3 and p of 4 could be calculated in the same way. Okay, and then when you are making the table of values, you make x is equal to 0, 1, 2, 3, 4, and then p of x is equal to x would be your probability column. P of 0, whatever answer you are getting, this would be in terms of k, so maybe you can write it as 2 over 3 to the power of 4k, right? And in this case, p of 1 would be 2 cube over 2, 3 to the power of 4k. When you simplify this part, it will be 2 cube divided by 3 to the power of 4k. The power is 2 power 4 here, and here it is 2 cube, and here it is 2 to the power of 2, and this is 2, and this is 2 power 0, which is 1. Okay, so this is the probability distribution table that you have already done for x is equal to 0, 1, 2, 3, 4. Now the question is find the value of k. So in order to find the value of k, you need to use this concept that when you add all the values of p of x is equal to x, the total value is equal to 1. This is just now we identify this, right? So in this case, if you pick up all those values here, it would be 2 to the power of 4 divided by 3 to the power of 4k plus 2 cube over 3 fourth k plus 2 square over 3 power 4k plus 2 over 3 power 4k plus 1 over 3 power 4k, and this is equal to 1. So you can just add up all these things, which would be k over 3 power 4 and 2 power 4 plus 2 cube plus 2 square plus 2 plus 1 equals 1, and you can find the value of k, right? Which would be 81 over 31. Okay, if you simplify this. So this is k, and if you go back to the question, you are asked to find p of x greater than or equal to 2, which means you need to add these three. X is equal to 2, x is equal to 3, and x is equal to 4. So for finding p of x greater than or equal to 2, what you need to do is you have to add p of x is equal to 2 plus p of x is equal to 3 and p of x is equal to 4. And you know what it is. Now you can substitute the value of k here, so which is p of x is equal to 2 was 2 square over 3 power 4k. So this would be 2 square over 3 power 4. Let me use this as 3 power 4 over 81. Sorry, 80, yeah, 3 power 4 over 31. Okay, plus 2 cube p of x is equal to 3 is here, 2 over 3 power 4 times 3 power 4 over 31 plus x is equal to 4 is here, which is 1 over 3 power 4 times 3 power 4 over 31. Okay, which would be 4 over 31 plus 3 power 4 cancels, 2 over 31 plus 1 over 31, which is actually 7 over 31. Okay, and that's it for the question here. Now let's try doing some problems with the concept of the probability adding up to 1. So if you add this plus this plus this plus this plus this is equal to 1, this is what we just did. Find the value of k. So these are some of the questions that would lead you to find the value of one of the probabilities which is not present in the table, using the concept that they all add up to 1. In some cases we also write p of x is equal to xi instead of that, and the sigma would be ranging from I equal to 1 to n. There is some books use this type of notation instead of just writing it like this. This is also correct, and in some notations this is also right. Okay, so here it is simple: 0.25 plus 0.2 plus 0.15 plus k plus 0.10 equal to 1, and you can find the value of k. Okay, that's not going to be difficult. Another question is you are supposed to find the value of beta, which means beta plus 2 beta plus 3 beta plus 4 beta equal to 1, which is 7 plus 2 9 plus 1 10. Therefore beta is 1 over 10. Okay, so find the value of beta is done. So what is when y equal to 2, which is equal to 2 beta, which is 2 over 10, which is 1 over 5. Okay, what is y range greater than 2? Remember, this is not equal to 2, therefore this is y equal to 3 plus y equal to 4. Probability of y equal to 4, which is 3 over 10 plus 4 over 10, which is 7 over 10 in this case. Okay, the next question is, you have a table of probability distribution here. State clearly what random variable represents. So this is Sally's number of hits in each softball match. So this is the number of hits which would be the random variable. Okay, find the value of k. Just you need to add them all and equate it to 1, and you can find the value of k. Probability of x greater than or equal to 2, you need to add 2, 3, 4, 5, all of them together. After finding the value of k, plugging them in here, and then add the values of k, 0 0.46, 0 0.08, 0 0.02, and then you can get the value of x, probability of x greater than or equal to 2. Probability of x between 1 and 3 would be including 1, including 3. Right, so adding up these three values would give you probability of values between 1 and 3. And that's it for this video. I hope you are clear about what is actually discrete probability distribution. You have understood what is probability distribution, and the sum of the probabilities in a probability distribution table adds up to 1. These are the major two concepts that you have learnt in this video, and try doing more problems from the PDF file which accompanies this video. Okay, see you, bye bye.